Now we're going to move on to Don Beavers with a company called, I lost my notes. I'm sorry, Sollensys.
Sollensys.
Yes.
Okay, let me tell you a little bit about Don Beavers. Right now he's an advisor, invited project mentor for the College of Engineering and Computing at Florida Institute of Technology. There he's the president, Probability and Statistics, specializing in database project development with blockchain applications for web, aerospace, and defense projects. So, Don, we look forward to hearing about your product.
Mark's go.
Well, thank you. Again, I'm Don Beavers, and our company is Sollensys, and we're deeply involved in blockchain software. We have a new product out called the Blockchain Archive Server, which is what we believe to be the gold standard of data backup. It is a system that is turnkey, that works with any platform out there, Windows, Linux, and it does not interfere with your current security setups. So it's an add-on, which makes it very attractive for many businesses. Our primary focus is on ransomware. That's been a huge problem out there, as everyone knows. It's a very, very serious concern. In fact, I was just seeing on TV yesterday that they had a school couldn't open for its first day because the school had gotten ransomware. And many, many municipalities have been hit with ransomware over the last year. It's a real problem. By utilizing our service, the client has an immutable, perfect backup of their data off premises, and it's stored in a way that is a distributed ledger so that their data is never in any one place at one time. So there's no single point of failure. And I guess to describe that, I'm going to go to the next slide here. Hold on just a second. Okay, so when a client has data come into their system, a copy of it is sent to a server that we have. It's a headless server that we have in their data center. And that server encrypts their data and then shreds it and distributes it to hundreds of thousands of nodes around the world. So you're taking their data and turning it into confetti and hiding it in different places. So when someone tries to acquire their data, it doesn't exist anymore. It's kind of quantum in nature. It's only there when you're looking at it. So when they want to recover their data, they put in a key fob and put in the right credentials, and then their information is pulled from those many locations into one location and then decrypted and then uploaded to their server. So with this system, any kind of disaster that they have at their facility, whether it be a fire or a natural disaster or some type of employee that went rogue and started destroying their data, or even electromagnetic pulse going off over their city, their data isn't there on their premises anymore, and it isn't in any one location anymore. So it can't be destroyed by the bad guys. So that's basically what we do. And I guess I reserve the rest of my time for questions.
Very good. Thank you very much, Don. So you've got 2 minutes extra for the judges' questions, and we'll start. Dan, who are you going to go to? You're still muted.
Yeah, let's start with Glenn.
Yes. So interesting presentation. Thank you very much, Dan. I'm sorry, Don. I heard similar presentations on blockchain previously, and I'm just trying to understand how this differs from those past presentations. So you have the similarities that I've heard about for the attribution and the separation of data over multiple points. So I'm just trying to find out what's the differentiator that you're presenting in terms of how your company is achieving success here.
Absolutely, thank you for that, and I apologize for the earlier presentation. Scientists don't make good salespeople, so I probably should have had someone from marketing come and talk to you, but I can't answer your question. Ours is significantly different than previous versions out there. Ours is actually double encrypted in that we take the blocks of data and we We encrypt those, and then we take the hash and put it on a completely separate network, encrypt and shred that too. So we're using two blockchains, one for the data and one for the hash, which makes it exceedingly difficult, theoretically impossible, to actually come through and steal that data. Another difference between us and most folks out there is for the last 3 years, we've been working on enterprise-level blockchain projects and have had good success with them. We've put 4 full-scale blockchain projects in the stream of commerce today. The advantage of that is most of our competitors are still talking about systems and thinking about systems. They don't have a commercial system out there. Ours is actually in use, fully functional, tested, and available for delivery immediately. That's a big difference between most of our marketplace out there. Since we made it compatible with any platform, we can have this installed in most businesses in 2 or 3 days and not 2 or 3 months or a year or so like it used to be. So I think the difference is that we have a proven track record and more experience in this than most have, and we have a product that's ready to put in the marketplace. I mean, they're ready to put in your business today.
All right, thank you, Don.
Certainly.
Lori?
Yeah, hey, you know what, Glenn, you stole my question, but I can come up with another one. What kind of price point are you looking at? I mean, I used to run a small business. Your data's critical. So how do you price your product?
So that's the big advantage. In the past, we've worked with some big agencies, government agencies and big corporations, and you're usually looking at anywhere from $1 million to $1.5 million to put a package together. We came out with this product with the purpose of democratizing this technology. Your average ransomware attack cost around $60,000 in actual cash to get your data back from the bad guys. And then there's usually a few days worth of downtime, business continuation problems, and the lot. With us, the entire system is $45,000 complete, ready to go and installed, which is about 75% of what one ransomware attack would cost. And of course, we have ways to finance that over the years or so. So this is, we believe, the most economical system on the market. And that's not $45,000 a year. That's a $45,000 one-time purchase, and then a couple $1,000s a year for upgrades and 24-hour service. And if something does go bad, and you do have a ransomware attack, you get up to 80 hours worth of tech time for us to send our technicians out there to get you back up and running, which is pretty nice. In fact, that's probably worth as much as the server is. So if you do get hit by ransomware, you have all of your data in immaculate, perfect condition. We'll send the troops out to come get your system back up online for you.
Don, thank you.
Brian? You're muted.
There we go. A couple of questions. First, have you called Garmin?
Actually, we have folks working on that. They're the insurance guys, right? Am I correct?
No, they're the GPS guys that ended up paying a large fortune recently.
No, I'm sorry.
Ransomware.
Every time you drive into work in the morning, you hear about another outfit that got their data stolen, you know? So
the question I have, since Lori and Glenn stole both of my questions, is what's the con-op for this? Is it installed locally and then the data is copied to the cloud? And are the users able to retrieve data in near real time, or is this something that the enterprise ops team would do in some sort of a transactional model with the end user?
Okay, so to answer your first question, the data is stored on they have some what are called master nodes here in the States. I have about 700 computers that we have at our facility in Florida, and there are other nodes around the country, and the rest of the data is sort of parsed and dispersed amongst the whole network. It doesn't go sideways from, obviously some countries want all of their data kept only in their country. Canada's like that. It's against the law for you to store your Canadian data back in the United States. It's I can see their point in that, but it's not, it's not very good security. But the data is no longer data after we get it. It's been absolutely shredded, and it's quantum in nature. It's so small, there's nothing you can do with it. So as far as where your data is, well, your data really isn't in any one place. That's the whole beauty of the system. So there are no, it's copied so many times that you can't lose it. That's another thing if one of the systems goes offline. What was your second question?
30 seconds?
Well, it had to do with how the users how do the owners of the data interact with it? Is it the IT team that treats it like a tape backup environment?
Exactly. It is incredibly easy. It's basically if you're replacing a database, you can drop your current database, put your key fob in, put your credentials in. Your database can upload. They can choose what they're uploading, uploads to their system, and they're up and running in very fast time. It's exceedingly fast.
And that's
in fact, it's mostly dependent on their bandwidth.
That's time. Thank you very much. Excellent presentation, John Beavers from Sollensys, and excellent questions, even though they keep stealing them from each other.